Give me a second, guys. Hold on. I really hope it works now. Oh my goodness. I don't know why. It kept, it just kept, what is it called? Like, it kept telling me, that there was just problems with the stream. Hopefully now it's good. Let me put this over here just so I can actually see what's going on. Okay. Okay. Hopefully, let me put this, actually, I'm gonna put this right over here as well. Just so I know exactly. Okay, hold on. There we go. And then, let me grab, or actually, hold on. Go over here and grab, click pop out chat, and then put it right here like this. Or maybe I can just put it like this, so that way it can look right. Okay. Alright, so hi guys. Welcome. So, I don't know who's whoever watches this stream, but anyways, I'm going to be streaming, and I'm gonna be going over, so basically I'm gonna just be going over college algebra, trigonometry, and precal, just some random questions. Hold on. I'm gonna look for the God, take that off. Let me go ahead and look for okay, give me 1 second, guys. Hold on. So, I'm gonna go ahead and put oh gosh, what is it called? Quizziz? I think it's called Quizziz. I mean, there's also Kahoots, but I don't know. I'll just do quizzes since it's kind of I would say it's the better one. Well, not the better one, but it's just an option. So give me a second, everybody. I'm gonna go ahead and I'm gonna go ahead and just enter my information here. So hold on. Give me a second, everybody. Hold on. I'm gonna enter my information if I can. So actually, hold on. Go back. So give me a few seconds, guys. Give me like a minute or so. I'm just gonna go ahead and enter my so I can log in. Hold on. Okay, so give me 1 second, guys. I'm gonna go to the bathroom very quickly. We'll get started in a little bit. So give me 1 second. I'm gonna just go ahead and I'm gonna use the bathroom very quickly. Okay, everyone, I'm back. Sorry, I had to go get some cereal. Maybe I can do face cam. I mean, I can try it. Let me see. Hold on. Give me a second, everybody. I'm gonna go ahead and, oops. Okay, let me put, hold on. Put this on top of here. But let me go ahead and put this like right here or so. Maybe that'll look better. Okay. So, and I hope you guys don't mind me eating. Okay. Let me. So I hope you guys can still see me. I know because I have the screen right here, or maybe I can do it like this. Hold on. Give me a second. I can probably do it like this. And I can just try to work it out. Like this. And let me turn this light on instead. So, have better lighting. And let me turn. Okay. So let's take a look at these questions, or maybe I can do, hold on. I'm not 100% sure because I know there's there's various amounts of what is it called? Quizzes and all that kind of stuff here. Let's see. Maybe if I put Algebra Final Exam Review. Trying to see if maybe there's one with a good enough questions, like good amount of questions, because I really, so let's see, hold on. Okay. So hopefully, Okay, so I'm not gonna, I can't promise that I'll know everything about this, but, so hold on, actually, let me see. Okay, there we go. As long as I can see the chat. I don't know if anybody's watching, but if anybody's watching, welcome. So, let's look at this question here. It says, given the function f of x equals 3x times, or 3x minus x squared, to find f of negative 2. So let's look at this one. So we have f of x equals 3x minus x squared, I think. Yeah. And then we want to find f of negative 2. So we have 3 times negative 2 minus, so what you're going to do, you're going to plug in negative 2 for x, so then you have 3 times negative 2 minus the quantity negative 2 quantity squared. So this would be f of negative 2 is equal to negative 6 minus 4. So f of negative 2, because we have minus and then negative 2 squared is just 4, right? Right here. I don't know if y'all can see my mouse. I'm not sure. But right here, so let me just highlight it. So, okay. So, I'm not sure why. Give me a second, guys. I'm gonna try to so one note. Okay. I'm not sure why, it keeps, it was not working right for a minute. Put this down a little bit, right here. Put it right here. Okay. So as long as I can see the, actually, let me go ahead and do this. Hold on. Go ahead and do this like that. And then, I guess I can just keep it like this. So anyways, let's look at the problem again. So, just look at it like this. So, and okay. So here we're gonna have f of negative 2, and we know that, so basically, oh, how can I do this? So basically, this part, so hold on. This right here is 4. So then we have f of negative 2 is going to be negative 6 minus 4. That's going to be negative 10. So that's your answer for this one, okay? Let me, hold on. The thing is, I have a monitor right here, and I also have this over here, so I'm kind of like, I'm writing from my laptop, but I am also looking at my monitor to make sure that the stream is running well. So the answer for this one would be negative 10. Yeah. Let me actually, hold on. So let me, I don't know if they're actually, I don't want to do a live quiz. I want to do like a, what is it? Thing about this one is that oh, that's not what I wanted to do. The thing about this is that not all of them are like not all of them are like, you can't play it by itself. You know what I mean? It's a little bit weird with this one. Is there an actual way that I can do this without, I think I can, hold on. Oh, there we go, hold on. Okay, so we have about, so here's the timer up here, and it's saying solve the system of equations. So we have 3x minus y, so 3x minus y equals 17, and negative x plus y equals negative 7. So I'm not sure why it keeps doing that. Hold on. So what you're gonna do systems of equations by elimination. Let me see, hold on. X plus y equals negative 7. Okay, I got it. And what you're gonna do for this one, so it's already eliminated, so we can eliminate y. We have 2x equals 10. So we have 2 on both sides. We have x equals 5, right? And then we can plug 5 back in. So then we have negative, actually, negative the quantity 5 plus y equals negative 7. So then we have negative 5 plus y equals negative 7. You add 5 on both sides. You get y equals negative 2. So your answer should be 5, negative 2. Okay. This one. Give me a second, guys. Let me do something very quickly. Alright. Sorry about that, guys. Give me 1 second. Hold on. This one says simplify 64 to the 1/3. So 64 to the 1/3. If you look at it, so 64 to the 1/3 power, that's equal to the cubed root of 64, and I believe they're asking for the positive cubed root. So you're gonna do 4 times, so basically you have, let me actually make sure that, okay, sorry guys. So, this one is gonna be equal to, so we have the cubed root of 8 times 8, and we know that the cubed root of 8 is equal to the cubed root of 2 times 2 times 2, which is literally just the cubed root of 2 cubed, which is equal to the absolute value of 2. So it's going to be 2, and then you have, so it's going to be both of these, right? So basically the cubed root of 2 cubed times the cubed root of 2 cubed, that's going to be 2 times 2, which is just 4. So that would be your answer. Oops, my bad. This one would be 4. Okay, this looks like, what is it, Precalculus? So consider the sequence 4, 1, -2, and -5. What is the 65th term of this sequence? Okay, hold on. Maybe I can find this one. So we have 4, 1, -2, and -5. So 4, 1, -2, -5. And we have, this is A1, this is A2, this is A3, A4. If we do a -3, so we obviously know that it has a common difference of 3. And we know that the, what is it called? So oh boy, not again. Hold on. I'm not sure why this is happening, guys. I keep seeing the, I keep getting that for, I don't know why, I keep getting on my, what is it called? Give me a second, guys. Give me 1 second. I'm gonna, I'll be right back. Give me 1 second. Let me just, actually, turn off music. Give me 1 second, guys. I'm gonna take a look at the stream through my phone because I don't know why. I'm not sure why it keeps saying error, YouTube is not receiving enough video. Give me 1 second, everybody. I need to take a look at this because I don't know. I don't know what's going on. What's going on? Okay, never mind. Never mind, it is working. It is working. I don't know why it kept giving me this. If you look, so I can probably just show you guys, but basically it kept saying YouTube is not receiving enough video. Whoever is in the stream, if you could let me know if it's not working, that would be great. Like, from your end. Anyways, let's resume. So, okay, so the way that you're gonna do this one, so let me actually, I'm gonna pause it. Let me go back here on OneNote. And so here we obviously know the common difference. We have, okay, hold on, give me a second. So we have, the common difference is 3. We know that for arithmetic sequence, here, you're gonna have, oh, let me take this off. You're gonna have, I believe it goes a sub 1 plus d times n minus 1, and where d is a common difference, and I believe I went over this in my precalculus, what is it called in my precalculus playlist, or my precalculus videos. I went over this. So the first, we know what a1 is. A sub 1 is 4, right? 4, and then we have plus, and then the common difference is negative 3 times n minus 1. That is what a sub n is here. So obviously we have negative 3 times n minus 1 plus 4. So here, if you take a look at this, okay, hold on. Sorry guys, I don't know why. It's just having complications today. Hold on. So we have a sub n equals negative 3 times n minus 1 plus 4. So a sub n equals negative 3n, so we're going to distribute 3 plus 4, so then we have a sub n equals negative 3n plus 7. That is our formula for this sequence. Now, it says, and let me go back. It says, what is the 65th term of the sequence? So we want to know what a sub 65 is. So we're going to put a 65 equals, and then we're going to plug in 65 for n. So we have negative 3 times 65 plus 7. And if you have a calculator, so we have negative 3 times 65 plus 7. That's about negative 188. So this should be negative 188. Okay. Oh, where was it? Over here. So yes, negative 188 should be your answer. Okay, so solve the inequality. So let me copy this down. -2 times the quantity. Let me go back. Hold on. And actually, let me use, because I feel like I'm not using the right. Am I using the correct notebook? Maybe that's why it keeps crashing. Give me a second, everybody. Okay, I'm not sure why it keeps crashing on me. Let me go to a new page. I'm just gonna put this. Okay. Let me go back. Let me go back here. We have this question. It says -2 times x minus 3 is greater than 36. So what you're going to do, you're going to go ahead and distribute in the -2. So you're going to get -2x plus 6 is greater than 36. So I can go ahead and subtract 6 on both sides. You should get -2x is greater than 30. So then once you divide, you divide by -2 on both sides. And when you divide by a negative, remember the inequality switches, so it's going to be x is less than -15. Okay. So it'd be this one. Okay. It says find the vertex of the following quadratic function, x squared plus 6x plus 5. Okay. So y equals x squared plus 6x plus 5. And then we have, we want to find the vertex of this function. So remember the vertex is, in this form, it's going to be -b over 2a, comma, f of -b over 2a, and f of x, we can rewrite this as f of x equals x squared plus 6x plus 5. And we know that the vertex is x equals -b over 2a. Here, a equals 1, b equals 6, c equals 5. We have it of the form y equals ax squared plus bx plus c. Okay. And so you go ahead and say x equals negative the quantity 6 over 2 times 1. So then this is equal to -6 over 2, which is equal to -3. So the axis of symmetry is x equals -3. Now to find the y term, you just plug it back in. F of, let me color code, -3 is going to be equal to, and let me make sure how much time is left on this one. Okay. F of -3 is going to be equal to the quantity -3 squared plus 6 times negative 3 plus 5. Okay, so you're going to simplify that. You have, so negative 3 squared is 9, and then 6 times negative 3, that's negative 18, and then you have a plus 5, so then you have this is equal to oops, I don't know why. I don't know why I did that. Anyways, we have negative 9 plus 5, and then we have that this is equal to negative 4. So your vertex is negative 3, negative 4 for this one. Okay. So this one, what is the inequality of the line shown? So obviously, if it's dashed, you're not going to have a line under the inequality, okay? So that crosses this one out. We know that, because it doesn't, you know, basically you don't have, yeah, if it's a line, a dash under the inequality, that means that it's going to be a solid line. This is a dashed line, okay? So if it has a line under the inequality, it's a dashed or a solid line, and this is not solid. So it's going to be one of these. So what we need to do is we need to test. So all the shaded values here, so any point that's in this shaded area should satisfy any of the following equations. Now, another way we can do it is we can find the what is it called, the slope of the line, and also so here, obviously, if I actually do a little snip and sketch here, or a full screen snip here, I can look at this and I can say that this is equal to, so basically we have a point here, and I don't know if you guys can see that, but let me actually, we have a point right here and a point over here. This is 0, negative 1. This is negative 3, 0. Okay. Now, looking at the equation, what you're going to do is you're going to go ahead and find the slope. So, find the slope between those 2 points. The slope, obviously this is x1, y1. This one is x2, y2. So then x1 equals, let me actually, so x1 equals negative 3, y1 equals 0, x2 equals 0, and y2 equals negative 1. Now go ahead and use the slope formula, so m equals y2 minus y1 over x2 minus x1. This is then going to be, so we have negative 1, so our slope m, if you look at it, will be negative 1 minus 0 over 0 minus negative 3. This is equal to negative 1 over 0 plus 3, which is just negative 1/3. Okay. And I hope y'all can see that. I don't think... Let me actually, hold on. Oh, I wish I could grab the... So, obviously, if you do rise over run here, I mean, this is another way to do it, but if you do rise over run, you do 1 unit up and 3 units left. So m is 1 over negative 3. So m equals negative 1/3, right? That's another way you could do it. So we know that it's not going to be a, right? It's not going to be a. It's not going to be d. And the only thing left now is the inequality symbol. So that's the last part of this. Oops, my bad. Let's look at the problem again. So again, you want to test a point. So 0, -3, for example. This has to satisfy. So it has to satisfy one of the following equations over here. So we can test y is less than negative 1/3 x minus 1. So for y is less than negative 1/3 x minus 1, we have -3, and we say is that less than negative 1/3 times 0 minus 1. So then we have -3 is less than 0 minus 1. -3 is less than -1. That's true. So your answer for this one is going to be y is less than negative 1/3 x minus 1. Okay. Find the length of x. This is Pythagorean Theorem. Now, if you have a calculator for this one, it's recommended that you use it. So, give me 1 second, guys. So, this one is Pythagorean Theorem. So basically you have the following. So let me draw the triangle very quickly. Okay, we have a side length of 6 and 7, so the legs of this triangle are 6 and 7, and we have an x value here. Now Pythagorean Theorem says that when we have a right triangle and we have side lengths a and b and c, that means that a squared plus b squared must equal c squared, or c has to be equal to the square root of a squared plus b squared. Okay, now here we're going to do, so you can do x if you want. You can just say x is equal to the square root of 6 squared plus 7 squared. That's x is equal to the square root of 36 plus 49. And if you add that, so if you do that on the calculator, so because it wants it in decimal form, the square root of 36 plus 49 is about 9 point, so x is approximately 9.2, I'm going to say 9.22 rounded, so it'd be this one. Okay. Okay. it says, now, a multiplier of 0.8. That's interesting. This one's a little tricky because, okay, we know that the y-intercept is 0, 2. So y equals ab to the x. And I don't know why it keeps doing this, but we're just gonna work it out. So, we have y equals ab to the x, and it has a y-intercept of 0, 2, and it says it has a multiplier of 0.8. Now, I don't know if we can do this without knowing exactly what it would. We can test it, really. We can test it. So, for example, if I let 0.8 equal to a, I can say that 2 equals 0.8b raised to the 0 power. Now, this is not true, so that means that b has to equal 0.8. So basically, we have 2 equals a times 0.8 raised to the 0 power. So that means that 2 equals a and 0.8 to the 0 power, that's 1. So 2 equals a. So that means we're going to have the following. Y equals 2, and then we have times 0.8 raised to the x power. It's going to be this one. Okay? You have to kind of use your brain a little bit for these. You have to find ways to look for the answer. Okay, it says, which point is a solution to the system of inequalities? Now we can test the points. So if we look at 6, 2, so we have, hold on, we have y is, now we can test y is less than, and I think, hold on, give me a second, less than or equal to negative x plus 4, and y, we're going to say, is greater than x minus 2. So, we have, so we can test 6, 2, and we can say, okay, 6, 2, we have 2 is less than or equal to the negative the quantity 6 plus 4. 2 is less than or equal to negative 2, basically, which is not true. So this one cannot work. Negative 5, negative 10, so we have negative 10 is less than or equal to negative 5 plus 4, or negative of negative 5 plus 4, excuse me. So then we have negative 10 equals, or not equals, negative 10 is less than or equal to 5 plus 4, which is going to be negative 10 is less than or equal to 9, which is true. And then we can also do it for the other one. So we have, so again, our point is negative 5, negative 10. So then we have negative 10 is greater than 5, or negative 5 minus 2. Negative 10 is greater than negative 7, which is false because negative 10 is actually less than negative 7. So it can't be B either. 1/8, we do, oh Lord, hold on. Give me a second, guys. I'm trying to see exactly. Okay. Okay, so let's test 1/8. 1/8. So 8, so basically 1 comma 8. If we do 8 is less than or equal to negative the quantity 1 plus 4, that's going to be 8 is less than or equal to 5. That's not true. Okay. And then if we do 0, 0, so if we do 0, 0, we have 0 is less than or equal to 0 plus 4, which is 0 is less than or equal to 4. And then we also have 0 is greater than 0 minus 2, which is 0 is greater than negative 2, which is true. So our answer for this one is going to be D. Okay. I'm hoping this makes sense. I'm not 100% sure, but yeah. Okay, so what is the equation of the line that passes through the points 2, 9, and 22, negative 1? So the way that you do this, so you're going to grab the points 2, 9, and what was it? And 22, negative 1. So this, so if you look in, if you kind of like, you know, sketch the graph, you have, so let's pretend this is 2, 9. So like about right here. And then 22, negative 1. And negative 1 is kind of like right here. So we know that this one is x1, y1. And this one's x2, y2. So to find the equation of the line, we first have to find the slope. The slope is going to be m equals y2 minus y1 over x2 minus x1. So we have negative 1 minus 9 over 22 minus 2. This gives us negative 10 over 20, which is equal to negative 1/2. Okay, so m equals negative 1/2 for this one. And then you want to go ahead and you can either do point slope form or slope intercept form. Since they're asking for it in slope intercept form, what we're going to do, we have y equals, and we have y equals mx plus b. So we know the slope is negative 1/2. Y equals negative 1/2 x plus b. And we just want to plug in any of these 2 points. So x equals, so let's do x equals 2 and y equals 9, right? So we have 9 equals negative 1/2 times 2 plus b. So then that gives us 9 equals negative 1 plus b. That's going to give us 10 equals b. So now we know that m is negative 1/2, and b is equal to 10. So that means that we're going to have y equals negative 1/2 x plus 10. Okay. Okay, so this one says, write the following quadratic and vertex form by completing the square. Now, since it's asking to do it by completing the square, we're going to do it that way. So we have x squared, it's plus 12x minus 4. And we're going to set it equal to 0. And why? Because to do completing the square, you have to set it equal to 0. We know that y equals x squared plus 12x minus 4. All right. Now, so what we're going to do, we're going to add 4 on both sides, okay? And then we have x squared plus 12x, and we're going to go ahead and put plus c here. And we're going to put a 4, and then whenever we add something to one side, we add it to the other side as well. We're going to put plus c on both sides. Okay. And it makes sense. Like, once you see why, once you see how it's done, you start to understand why we add c on the other side as well, and why we add a c and make it equal, like, why we subtract or add this part, like this specific part, etc. So then we have x squared plus 12x plus c equals 4 plus c. Now we know that c, we have to remember that c equals b over 2 quantities squared. So here we have a equals 1, this is a, this is b, and this is c. So b is equal to 12, so that c has to equal to, and what I mean by c, I mean like after you added it over here. I don't mean the c part here where it's the third term of the original quadratic. So we have c is equal to 12 over 2 quantities squared. And that's going to give us c is equal to 6 squared. So that means that c equals 36. So that means we have x squared plus 12x plus 36 equals 4 plus 36. So then we have x squared, x squared plus 12x plus 36 equals 40. Now, what you want to do now is go ahead and so what you want to ask yourself, 2 numbers, and you don't have to do the box method here. You can just ask yourself 2 numbers that multiply to 36 and add to 12. Well, that would be, let's see, that would be 6 and 6, right? X plus 6 times x plus 6 equals 40. Okay, so that's going to give us x plus 6 quantities squared equals 40. So then, if we set that equal to 0, we have x plus 6 quantities squared equals, minus 40 equals 0. So then that would be y equals quantity x plus 6 squared minus 40. And that is the vertex form of this parabola. Yes. Okay. Oh boy. So it says Shirley starts with $85 in the bank and saves $15 every 2 months. So that means that she started with $85. So that's your y-intercept, because that's what you start with. That's at t equals 0, she started, t being the x-axis, she started with $85. That means that for y, when x equals 0, y equals 85. So that's your y-intercept. Now the y-intercept is always your b value. So obviously, looking at these choices, so it says, okay, and then it says she saves $15 every 2 months. So that means that she's going to have, oh, this one's hard. So I'm wondering if it'll be 2m, hold on, $15 every 2 months, x being the amount of months. So it's saying that it's 15x over 2, so that means that every month she's going to be saving, I believe, $7.5. So a lot of people can get tricked and say that it's I mean, obviously, actually no, but because it would be this one, because she started with 85, so that should be it should be this answer automatically. Okay. Like I said, it's really important when you're reading the question to look at your choices. Okay, so it says find the zeros of the function using the quadratic formula. So we have 4x squared plus 14x plus 6. So y equals 4x squared plus 14x plus 6. And so we have 4x squared plus 14x plus 6 equals 0. So we're going to solve this using the quadratic formula. Now, the way that I would do this is, first I would reduce this, right? Because you always want to make sure you always want to make sure that you can simplify this expression. So that means we're going to have 2x squared plus 7x plus 3 equals 0. Now go ahead and use the quadratic formula we have. So obviously this is A, this is B, this is C. And the quadratic formula says we have negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, so this is going to be x equals negative 7 plus or minus square root of 7 quantities squared minus 4 times 2 times 3 all over 2 times 2. So then we have x equals negative 7 plus or minus square root of 49 minus 24 over 4. And then we have x equals negative 7 plus or minus square root of 25 all over 4. So then this gives us x equals negative 7 plus or minus, and the square root of 25 is just plus or minus 5 all over 4. So we have x equals negative 7 plus 5 over 4, or x equals negative 7 minus 5 over 4. Now, simplifying this, we have x equals negative 2/4, which is equal to negative 1/2, or x equals negative 12 over 4, which is equal to negative 3. So our solutions are x equals negative 1/2 and x equals negative 3. Okay. And that's how you do it for that one. Oh boy. The number of bacteria present in a colony is 180 at noon, and it increases at a rate of 22% per hour. How many bacteria will be present 4 hours later? So this one is tricky. It's very tricky. I believe... Oh my. This one's a little tricky. I'm just gonna go ahead and guess on this. I'm really not sure on this one. I'm really not sure on that one. So, okay, this next one, oh crap. Oh no. Okay, this one was x squared plus 6x plus 9, obviously. When you do FOIL method, you'll obviously get that. This one, if you look very closely at the graph, you see that from this point here, so we know that the slope, or the y-intercept, it goes from 1, 2, 3, 4. The y-intercept is 2. That means that b in y equals mx plus b is going to be 2. So in reality, the only one that has that is C, okay? Okay, this one says 14x cubed, y squared over 2x to the 4th y. So 14x cubed y squared So this one says 14x cubed y squared over 2x to the 4th y. This is going to be equal to, so we have 2 times 7 times x cubed times y, right? Over, and we're going to do 2 times x cubed times x times y. You always want to make sure that you put it in the form so that, and if it helps, you can always just do like, you can do it this way, so you can say 2 times 7 times x cubed, or times x times x times x times y, and then 2 times x times x times x times x times y. You can do it that way, but know that when you have bigger numbers, it's not always going to be that easy. I always recommend that you just remember your laws of exponents. So for example, you can say that this is equal to 7, and then it's going to be x, 3 minus 4 is negative 1, and then y squared over y, that's just y. So then you have 7 times 1 over x times y, so then you have 7y over x. That's how you would do it. That's how I would do it, actually. Okay, so this one, they have a little interesting picture here. This is our function. This is how they would define it whenever you have a basic function and they say, oh, if you put in x, what will we get for f of x? Now, x is your input and f of x is your output. Now it's saying that what is the input if the output is 21? So that means we have to set negative 6x plus, or negative 6x minus 3 equal to 21. So if we do that, we get that negative 6x equals 24. So we go ahead and divide by negative 6 on both sides. We get x equals negative 4. Okay. So this is the second to last question. It says, simplify 2w to the negative 2 raised to the 4th power. So, let's see. This is really just 2w raised to the negative 8 power. Now, or actually, hold on. No, it's not. I'm kidding. I'm wrong, actually. This is, so it's going to be, anytime you have a x raised to the n raised to the m, you're going to do a to the, so I would always look at the very inside first, this part. And I would say that this is equal to 2 raised to the negative 2w raised to the negative 2 raised to the negative, or raised to the 4, excuse me, not to the negative 4. So, let me see, hold on. Right, and then I would say that this is 1/4, so it's going to be 1/4 w squared, and then we know that this is all raised to the 4th power. Now I can say the following: this is 1 raised to the 4th power over 4 raised to the 4th power times w squared raised to the 4th power. This is then equal to 1 over 4 times 4 is 16, times 4 is 64, times 4 is, I think it's 256, and then it's going to be w raised to the 8th power. Wait, hold on. I feel like I did something wrong. 2w. Oh, my bad. This isn't, okay, hold on. This one's different. My bad. I messed up. This one is, okay, so for this one we have, so it's just gonna be, let me try to, so it's 2w And hold on. Two W. Okay, 2W to the negative 2 raised to the 4th power. So it's going to be 2 times 1 over W squared. And all of this is going to be raised to the 4th power. So then we have 2 over W squared raised to the 4th power. Remember that x to the n, or anything, so basically we have x over y, if we have that raised to the nth power, that's going to be x to the n over y to the n. And then, so then this is going to be two raised to the 4th power over w to the 8th, which is really just, so it's going to be 2 squared times 2 squared over w to the 8th, which is really just 4 times 4 over w to the 8th, which is 16 over w to the 8th power. Okay. It's this one. Okay. This is the last one. Given the function f of x equals 3x minus x squared, find f of negative 2. So, f of x equals 3x minus x squared. So we want to do f of negative 2. That's going to be 3 times negative 2 quantity squared minus, negative 2, and then we have that this is equal to 3 times 4 plus 2, which is equal to 12 plus 2, which is just 14. So f of negative 2 hold on. Oh, 3x minus x squared, my bad. It's 3 times negative 2 minus, and then you go negative 2 quantity squared. So it's going to be 6 minus, and then negative 2 squared is just 4, so it's going to be 2. Actually, hold on. Negative 6 minus 4. And then this is going to be negative 10. There we go. Ugh. Oh my goodness. All right. Okay, x plus 3 quantity squared. What I meant by that one was this. Hold on. So, to do this one, if you really don't know how to do it, you can just do FOIL method. So, this is equal to x squared, and then you do plus 3x, and then plus 3x, plus 9. This is just x squared plus 6x plus 9. Okay. It's this one. I'm really not sure about this one. I don't know. I guess. I mean, this one's weird. I'm not 100% sure on that one. It's a little bit difficult. Okay, so let's go ahead and exit, and then we're gonna go ahead and do, so now, let me, let me do some trig. Okay. So hopefully, let's do trig identities. I want to do trig identities, and then I'll go over, what is it called? Forgot what it was called. Trig, like the trig ratios or whatever. Let me do one. I mean, let me see, hold on. I want to see. Okay, well, hold on. This is interesting. Hold on. I want to look for, let me see, trig identities. So maybe we can do these or this one. Thing is that okay, these are pretty simple. We're just gonna go, let me actually, hold on. I'm gonna try to do trig identities with just like from, what is it called? From Varsity Tutors, maybe, because I know they have a lot of practice problems. So let me go ahead. I'm trying to see exactly how to do this one. Hold on. I'm trying to see exactly what trig identities I can do, because I know there are some, and I'm looking to see if maybe okay. Okay, let me actually, I'm gonna just look up online. Trig identities, practice problems. Okay, so let's look at some practice problems for trig identities, okay? Now, I may or may not have gone over these before in some of my other YouTube videos. Trying to see exactly. Okay, so let's do one of these. Hold on. So so we have tan x plus cosine x over 1 plus sine x equals 1 over cosine x. So this is going to be equal to, so obviously the right side, the left-hand side is more complicated, so we're going to do that one. And we're going to leave the right-hand side alone. So we have, so obviously this tan x is going to be equal to sine x over cosine x. Cosine x, and then we have plus, and then we do cosine of x over 1 plus sine of x. So then we want to do the following. So we have sine x over cosine x, and then we do plus, and then we're going to do cosine x over, and then we're going to do 1 plus sine x. So now we're going to do that rule, and if we make this equal to 1 over cosine x, and this is equal to 1 over cosine x, so then we do that rule. If we have a over b plus or minus c over d, that's going to be AD plus or minus BC over BD. So we can do that here. We're going to do sine of x times the following. So it's going to be 1 plus sine of x. And then we have plus, and then we do, so cosine x times cosine x, that's cosine squared x over, and then we have cosine x times 1 plus sine x, and then we do sine x plus sine squared x plus cosine squared x over cosine x times, or it's going to be So let me, okay, I'm gonna leave the bottom part like unfoiled or undistributed. So basically, I'm gonna say that this is equal to, it's gonna be cosine x times 1 plus sine x, because you always want to make sure that something cancels out. If something cancels out, it'll tell you. So then we have sine x plus 1 over cosine x times 1 plus sine x. And you see that this is equal to 1 over cosine x. Now then we have the following. 1 times sine of x plus 1 over cosine of x. And then it's going to be times 1 plus sine of x. So this cancels out, and this is equal to 1 over cosine x. So we verified the identity. 1 over cosine x is equal to 1 over cosine x. Okay? That's how you do it. Let's do one. Let me see. Hold on. Maybe. Let's do a harder one. Maybe they do have harder ones, but I'm not sure. Let's do a tough one, or let's do a moderate one. I want to do a moderate one. Maybe a moderate one. And again, maybe these were some that I already did in the past. So, yeah. Okay, so we have 1 minus cosine x all over sine x plus sine x all over 1 minus cosine x is equal to 2 cosecant x. So we're going to go ahead and do the rule. So that means we're going to have the following. 1 minus cosine of x times 1 minus cosine x plus, and then we have sine of x times sine of x all over sine of x times 1 minus cosine x is equal to 2 cosecant x. Okay, so this, you're going to do FOIL method, so you have 1 minus, and it's going to be, okay, so here's the thing. You can rewrite this, and this is why this is tricky, because some people can FOIL this out, and then you can do plus sine squared x and all that stuff. But you don't have to do that. And there's a reason why. That's because, so what I'm trying to say here is that what you can do is you can turn this part into 1 minus cosine x quantity squared, and then you can turn this part, so hold on, this part you can do it squared, so it's going to be plus sine x quantity squared, and this is equal, and then this is over sine x times 1 minus cosine x. Sorry guys, give me 1 second. Okay, so then this is going to equal to 2. This equals 2 cosecant x, so then we have... Okay. Oh, this is interesting. Okay, oh, this one's hard. Okay. I'm trying to think. This one can be... Okay, so then what you're gonna do, you're gonna go ahead and grab this, and this is really 1 minus cosine x quantity squared plus sine squared x over sine x times 1 minus cosine x is equal to 2 cosecant x. So then what you're going to do, this is really just 1 minus cosine x times 1 minus cosine x plus sine x times sine x. Yeah. And then you have over sine x times 1 minus cosine x equals 2 cosecant x. This one's hard. Let me see. Let me see. Hold on. So this one is gonna be, oh my, it's so we have 1 minus cosine x plus cosine squared x plus sine squared x over sine x times 1 minus cosine x equals 2 cosecant x. So then you have 1 minus 2 cosine x plus sine squared x over sine x times 1 minus cosine x. And I'm trying to see exactly how to turn this into 2 cosecant x. This is a tough one. This is equal to 1 minus 2 cosine x. And let me actually try to make this... Oh my. Times 1 minus cosine squared x over sine x times 1 minus cosine x. This is equal to 2 cosecant x. this is equal to 1 minus 2 cosine x plus 1 minus cosine squared x over sine x times 1 minus cosine x is equal to 2 cosecant x. And then you do 2 minus 2 cosine x and then plus 1 minus cosine squared x over sine x times 1 minus cosine x equals 2 cosecant x. And then this is equal to 3 minus 2 cosine x minus cosine squared x over sine x times 1 minus cosine x equals 2 cosecant x. This one's really, really, really hard. I'm not even kidding. Because I know that there's a way to do this one, but I'm trying to figure out what I'm doing wrong. Or maybe, maybe I don't have to do all of this. Hold on. This one's very difficult. So, hold on. Okay. I'm trying to see exactly. So, okay, so we can do the following. Right? We know that sine squared x is really just 1 minus cosine squared x. And we do 1 minus cosine x times 1 minus cosine x plus 1 minus cosine squared x over sine x times 1 minus cosine x. I think I made this more complicated than it was. Hold on. I do apologize. So this one would be 1 minus cosine x times 1 minus cosine x plus 1 minus cosine x times 1 plus cosine x over sine x times 1 plus, minus cosine x, excuse me. Now what you have to do is factor out a 1 minus cosine x. So basically you're going to have, so if you have AB plus AC, that means you can do, or wait, hold on. If you have A squared, excuse me, A squared plus AC, that means you can do A times, or let's say it's UV, or U squared plus UV. U squared plus UV. This equals U times U plus V. Okay. Now, that means that U equals to 1 minus cosine x. V equals 1 plus cosine x. So in reality, you're going to have 1 minus cosine x times the quantity 1 minus cosine x plus 1 plus cosine x over sine x times 1 minus cosine x. This one's hard, and it's a little difficult to understand because you have to use algebra. And the thing about this one is you have to look at it for a little bit, and you have to kind of analyze it a little bit and see, okay, what are we doing here, and why is it being done this way? So what I'm doing is, and I'm going to try my best to explain this. So basically I'm taking out a common term. The common term is 1 minus cosine x, obviously. I'm taking it out, right? And I'm putting it back in, so that way when you distribute, it goes 1 minus cosine of x times 1 minus cosine of x plus 1 minus cosine of x, which is this part, times 1 plus cosine of x. That's what I'm doing. I'm just factoring. Now, on the bottom, we already have sine of x times 1 minus cosine of x. So what does that mean? That means that we have the following. This equals 1 minus cosine of x times 1 minus cosine of x plus 1 plus cosine of x over, and this is going to be 1 minus cosine of x times sine of x. In reality, this is the same as 1 minus cosine of x times sine of x. Okay. They're the same thing. You're going to go ahead and you see that there's a common term. So basically, this is now its own term. And this is its own term, right? So now you go ahead and cross it out. And you're left with 1 minus cosine of x plus 1 plus cosine of x over sine of x is equal to 2 cosecant x. And what does that mean? That means that these two get canceled out, and you are left with 2 over sine of x equals 2 cosecant x. So 2 cosecant x equals 2 cosecant x. We verified it. It's a tough one. This one's very hard. You have to do factoring. You have to factor. It's a difficult one because, and I believe I've done this one before. It looks familiar to me. But yes, that's how you do it. Now, switch gears and let's go on to let's go on to was that one even moderate? I don't even know, to be honest. Hold on. Give me a second, guys. I'm gonna look at the one that we just did. Was that one really, really moderate? Like, was that one moderate? Oh lord, that one was moderate. Okay, so now let's look at a tough one. Let's look at a hard one. Okay. Oh boy. Okay, actually the hard ones are way harder. Hold on. I'm trying to see ones that are tougher. Let me see. Hold on. Hold on. I'm trying to see one that is more, like, more complicated. And if I'm taking a while, I do apologize. I'm trying to see. Okay, hold on. Hold on. Oh my goodness, I don't even know. Hold on. Which one did we just look at? One. Okay, so let's look at this one. Like I said, I feel like I've done this one before, but I don't know. I feel like at this point, because I've done them for so long, they all look the same to me, or I feel like I've seen them before. Okay. So okay. I'm gonna try to turn this into sine and cosine. So, and on the right side, I'm gonna just leave it the way it is. So basically what I'm trying to say, I'll turn it back to cotangent x and cosecant x after I'm done. That is if I do get the right, what is on, like, I do get the identity on the left equal. So the first thing we're gonna do, we're gonna go ahead and write everything in terms of sine and cosine. So this, and then also this here. Alright. So we have 1 over sine x plus cosine x over sine x over sine x over cosine x plus sine of x over 1. So we have this, and then we have this, and then we have, on the bottom, we have tan x, so it's going to be like this, and then on this part we have sine x. Okay. This is equal to cosine x, or I'm gonna just say cotangent x, cosecant x. So then we have 1 plus cosine x all over sine x all over, and we're gonna go ahead and simplify this part here. We're gonna have sine x plus sine x cosine x over cosine x is equal to cotangent x cosecant x. Okay. Now, we must use the rule a over b over c over d is equal to a over b times b over, d over c, excuse me. So that means we're going to have the following: 1 plus cotangent x over sine x, and we want to do it as a division of two fractions. Sine x plus sine x cosine x over cosine x equals cotangent x cosecant x. Okay. Now we're going to go ahead and do 1 plus cotangent x. Oh, and it's cosine x, my bad. One plus cosine x. So, and then it's going to be times cosine x over sine x plus sine x cosine x equals okay, I'm gonna just keep it as cotangent x cosecant x because I can't simplify it in terms of like, if I do, like, there's nothing to what is it called? Cross out if I simplify this in terms of sine and cosine, like the right side. So I have cosine x times 1 plus cosine x over sine x times sine x plus sine x cosine x. Okay, this part is going to be cotangent x. Okay. And then times, and we're going to have oh boy. Okay, oh my goodness. It's going to be 1 over sine x plus sine x cosine x plus cosine x over sine x plus sine x. Let me write that better. Plus sine x cosine x. So then we have this would be oh my goodness, cotangent x, and then we have 1 over sine x times 1 plus cosine x plus cosine x over sine x times 1 plus cosine x. So then we have cotangent x times 1 over, or it would be actually 1 plus cosine x, because the denominators are the same, so you can bring it together. You can bring both fractions together, like right here. So then we have 1 plus cosine x over sine of x times 1 plus cosine x. Okay, so on the right side, so basically we have the common denominator of 1 plus cosine x here, so we can cross it out. And then we have cotangent x times 1 over sine x. And this equals cotangent x cosecant x. And if you've been following, we verified it. Okay. Yes, this is how it is. All right. Now, let me do, I'm trying to think of what else to do. Let's try to do, what is it called? So for example, let's say, and let me do, right triangle trig. Okay, hold on. Give me 1 second, guys. I'm looking for, let's do what is it called? Like the s square root 3 and 45, 45, 90 and 30, 60, 90. Or actually, let's just do, I mean, yes, it's right triangle trig, but we're gonna do, what is it called? Some random problems. So let's pretend that we have this triangle, right? And this is angle theta. And this is 6, and this is 11. And I want to say solve for data, okay? So how are we going to do this? We know that this is a right triangle, so we can use right triangle trigonometry. SOHCAHTOA. Okay. And the is you would say, so if you look at the angle, you know that opposite over hypotenuse is equal to the angle. So like the sine of that angle. So basically sine theta, you can say sine theta equals opposite over hypotenuse. And you know that when you have a right triangle, when you have a right triangle, and that's your angle, this is opposite, this is adjacent, and this is hypotenuse. So sine theta, like we said, is opposite over hypotenuse. So, that means that sine theta equals 6 over 11. So to find the angle theta in degrees, so let me go ahead and let's just say we want to round it to the nearest degree. We're going to do sine inverse of 6 over 11. You want to make sure your calculator's in degree mode. So the angle theta will be approximately 33 degrees. Okay, that's how you would do that one. Ooh, this one's interesting. Okay. So let's say we had this problem. Okay. And yes, this is still right triangle trigonometry in case you're wondering. But hold on. Let me. So we have this triangle, and in the middle, so in the middle we have like that. And it says that we have 500 feet, or 500 right here, which is going to say 500. And it's saying that this length here is x, and this length over here is y. And it is also saying that we have another line here. So over here, we have a line going like this. Hold on. I mean, it's not a full line, but it's like just to indicate that this angle here is 31 degrees. Okay. And we also have, and let me see how, okay. We also have, this angle over here that is 25 degrees. And we want to find x and y. So, I mean, how are we going to do it, basically? So, okay. We can break this up into two different triangles. So, I mean, if you think about it, this is a 90-degree angle. And this angle here is really, we can name this like angle Z or whatever, right? So we know that because these two angles form a 90-degree angle, these two angles right here form a 90-degree angle, we can say that 90 is equal to Z plus 25. And if you subtract 25 on both sides, you'll get that 65 equals Z. So this is 65 degrees, okay? Now to solve for y, you're going to do, so it's going to be opposite over adjacent, right? Because opposite of 65 is y, so we have tan of theta is equal to opposite over adjacent, where if we have a triangle here, and this is our angle theta, and this is the right angle, and this is opposite, and this is adjacent, we can say that tan theta, we can say this basically, okay? So to find y, you're going to do tan of 65 degrees is equal to y over 500. Now we know that y is going to equal to 500 tan of 65 degrees, right? So y, so yeah, 500 tan of 65 degrees, that's going to be, so this is approximately, and I'm going to round to the nearest whole number, y is equal to 1,062 feet, because in reality, this is feet. The problem is in feet, and I believe it's a word problem. Now to find x, you're going to do the same thing you did. So basically, this height here, if you look at this height here, this is also 500 feet. So this angle here, oh, let me do another color. This angle here, this purple one, we're going to name this W. So W, so basically we have W plus the 31 degrees that we have over here, right, is equal to 90, because this forms a 90-degree angle, okay? So we're going to solve for W. Gosh. So we get that W is equal to 59 degrees. So we know that this angle is 59 degrees. Now, okay, so now we can do right triangle trigonometry. So we have, again, opposite over adjacent. We're going to do tangent. It's going to be the tangent one. So it's going to be tangent of 59 degrees is equal to x over 500. Okay. So that means that 500 tan of 59 degrees is equal to x. So that will be approximately 832 feet. So that means we have x and y, so that means that x equals 832 feet and y equals 1062 feet. Those are your two answers. Okay. I'm trying to see what other ones I can do. I feel like mostly I did most trigonometry here. I'm trying to think. Okay, let me... I think that... Yeah. I think that's it for this video, guys. This live stream. This was mostly trigonometry and algebra. So whoever watched, even if it was for a little while, thank you so much for watching. I'm gonna end it right here because I feel like we've already went, it's already long enough. So if anybody has any questions over anything that I went over in this live stream, let me know. And thank you so much for watching, guys. If anybody has any questions, like I said, yes, let me know. Please like, comment, and or subscribe, and I will see you guys in the next video. Thank you so much for watching, and I will see you guys next time. Bye, guys.